Jai Hind students, welcome to my YouTube channel. Actually, welcome to this episode. Students, success and failure, these are the two sides of the same coin. What I mean to say is that although failure is the antonym, that is opposite of success, but failure is a part of success. You can't separate these two. What I mean to say is that, students, success cannot be achieved without experiencing failure. No one in this world has attained success without experiencing failure. So the main point is, don't be afraid of making mistakes. We are all human beings. We tend to make mistakes. But the most important point is, after making mistakes, we need to rectify it and not repeat committing the same mistakes. That's the lesson which we need to derive. Right? So with that, students, let's begin this session. In the previous lecture, we have discussed laws of vector addition. We have discussed triangle law of vector addition, which is the basic law. Then we have discussed parallelogram law of vector addition. And then we have discussed polygon law of vector addition, all graphically, right? Today in this session, we'll be discussing the mathematical or the analytical treatment of triangle law of vector addition. Now students, let me repeat this statement. Triangle law of vector addition states that if the two vectors, here A vector and B vector, if they act at a point or a particle simultaneously, and if these two vectors acting at a particle or a point simultaneously be represented by the two sides of a triangle taken in the same order, then their vector resultant, both in magnitude and direction, is represented by the closing side of the triangle or the third side of the triangle taken in the opposite order. So R vector is the resultant of A vector and B vector. This is the graphical representation. Today what we need to discuss is, we will try to find out the mathematical expression for the magnitude of this resultant in terms of A, B and theta. Theta, students, it is the angle which A vector and B vector are making with each other. And in the previous lecture I have explained which is the effective angle between the two given vectors. The angle between the two vectors should be such that at that point either the two vectors should originate from that point, or at the given point the two vectors should terminate at that particular point. So that will be the effective angle, right? Here at point O, both the vectors are originating. So theta is the effective angle. So here what I have done is, this is vector A, equal vector. Now what I have done is, I have joined the tail of B vector with the head of A vector. So these are the two equal vectors having same direction and equal magnitude. So these two are represented by the two sides of a triangle taken in the same order. So in such a case, the resultant is given by this third or the closing side of the triangle taken in the opposite order, right? So let us consider this to be point A, this to be point N, this to be point N, and let us drop a perpendicular over here. This is through construction, so that is why I am representing it with dotted lines. This O, M, N, and suppose it is P. And theta is the angle which A vector makes with B vector. The direction of A vector at this point is like this, and B vector is like this. So theta is the effective angle, right, between A vector and B vector. Also let beta be the angle which the resultant R vector makes with A vector. Now the vector addition of A vector and B vector is R vector, which is itself a vector quantity. So we not only will try to find an expression for the magnitude of R, but we will try to find its direction as well. So the direction of resultant R will be represented in terms of beta, which is the angle which R vector makes with A vector. Right, students? So we need to express A, B in terms of theta and R. We need to find out the relationship. So what to do is, it's a right angled triangle. So in right angled triangle OPN. It's a right angled triangle. We can make use of Pythagoras theorem. Square of the hypotenuse is equal to the sum of the squares of the base and the perpendicular. So what you get is ON square. It would be equal to OP square plus PN square. Right? Let's solve it. OP square. Now this OP, it may be written as OM plus MP, isn't it? It may be written as OM plus MP plus PN square. Let's solve it. It's in the form of A plus B whole square. It is A square plus B square plus twice AB. So what do you get is OM square plus NP square plus twice OM into MP plus PN square. Clear, students? Okay. Now look, consider this small right angled triangle. In this small right angled triangle, in triangle MPN, again using Pythagoras theorem, we get MN square is equal to MP square plus NP square. So what we can do is NP square plus PN square. MP square plus PN square. It may be written as MN square. So students, after rearranging the terms, we get OM square plus, in place of MP square plus PN square, we can write MN square plus twice OM MP. Clear, students? Now, ON, its magnitude is R. OM, its magnitude is A. MN, its magnitude is B. OM, again its magnitude is A. MP. Now, our objective is to convert this MP in terms of MN and theta, so that we can write the result in terms of A, B and theta. So for that, students, what to do is, in this triangle NPN, it's a right angle triangle, you can consider cos theta. Cos theta is base over hypotenuse, that is MP divided by MN. So MP can be written as MN cos theta. Clear, students? So here in place of MP we can write MN cos theta. So what we get is ON square is equal to OM square plus MN square plus twice OM, and in place of MP we can write MN cos theta. Now let's substitute the values. ON, as I have stated, OM, its magnitude is R. So it will be R square, right? OM, its magnitude is A. So it is A square. We are trying to find out the magnitude of the resultant. MN, students, MN, it's a vector whose magnitude is B. So it will be B square plus twice OM, that is A, MN, that is B and cos theta. So the magnitude of the resultant, it's given by square root of A square plus B square plus twice AB cos theta. This is the master formula to determine the magnitude of the two vectors A and B which are inclined at an angle theta. So students, always remember, whenever the two vectors are inclined at an angle theta, then the magnitude of the resultant is given by square root of A square plus B square plus twice AB cos theta. Theta is the angle between the two given vectors, A vector and B vector, right? So this is the magnitude. Now this is only one part, because resultant being a vector quantity, it must possess both magnitude as well as direction. So one part is over. Now let's try to find out the direction which the resultant makes with A vector, and that we have considered to be beta. So now let's try to express angle beta in terms of AB. Okay, again we'll consider the big triangle, right angle triangle. So what to do is, let's consider triangle OPN. In triangle OPN, consider tan beta. This is the right angle triangle we are considering, and consider tan beta. It's perpendicular by base. So it is NP divided by base. Base is OP. It can be rewritten as NP divided by OP, can be written as OM plus MP. OM plus MP. Now we need to express in terms of A, B and theta. NP. We need to express in terms of beta. So consider sine theta. In this small triangle, consider sine theta. It will be perpendicular by hypotenuse. That is NP divided by Mn. So NP may be written as Mn sine theta. Right? So in place of NP, we can write Mn sine theta divided by OM. No need to change it. Its magnitude is A. So OM plus MP. We have already changed it in terms of Mn and theta. So MP is equal to Mn cos theta. What's the need to change these two? In order to express the result in terms of A, B and theta. Right? So what we get is, let's substitute the values. Mn, its magnitude is B sine theta divided by OM, its magnitude is A plus B cos theta. So students, this is the expression for the direction of the resultant R, which it makes with A vector. Tan beta, it's equal to B sine theta divided by A plus B cos theta. So these are the two very, very important expressions, right? Now what we'll do is, we'll discuss all the possible cases. And students, you need to remember each and every result, because while solving numericals or while doing some articles, we'll be directly making use of these results, right? So what we have done till now is, we obtained two very, very important expressions. We know that R vector is the vector result of A vector and B vector. This is the representation in the graphical form. In magnitude, the resultant, it's given by, just now we have proved, it is given by square root of A square plus B square plus twice AB cos theta. This is the magnitude. And students, just now we have discussed the direction. Tan beta. This is the angle which the resultant R makes with A vector. So what we have obtained is B sine theta divided by A plus B cos theta. So these are the two very, very important results, right? This gives the magnitude and tan beta, that gives the direction. Now what we'll do is, we'll consider the special cases. We'll consider the case when theta is 0, theta is 90 degree, theta is 180 degree. Then we'll be considering the case where the two given vectors are of equal magnitude. Then what will be the angle which the resultant will make with either of the two vectors, right? So let's consider the special cases. So let's start with case 1. Case 1 is when the angle between the two vectors, that is theta, is 0 degree. When the angle between the two vectors is 0 degree. So it should be like this, OA and B. So theta is 0. It means that we are talking about this. This is A vector and this is B vector. This is B vector. So what's the angle between these two? It is 0 degree. Angle theta over here is 0 degree. Right? So what will be the magnitude, students? Let's check it out. It will be square root of A square plus B square plus twice AB cos 0. Cos 0 is 1. So we'll be left with square root of A square plus B square plus twice AB. Students, it may be written as A plus B whole square. Whole square would get cancelled. So in this case, the magnitude of the resultant is simply given by the addition of the magnitude of the two vectors. Right? This is the magnitude. So what's the result? Whenever the two vectors are in the same direction, then the resultant is always given by the sum of the magnitude of the individual vectors. That is what we have proved, right? We have proved it graphically as well. Now what about the direction? Substitute theta as 0 over here. Sin 0 is 0. So it implies that tan beta, it would be equal to b sin 0 divided by a plus b cos 0. Sin 0 is 0. 0 divided by anything is 0. So tan beta is 0, which implies that beta is equal to 0 degree. So the resultant will make an angle of 0 degree with a vector or b vector. That is, in this case, the resultant will be directed along the direction of a vector and b vector itself. So beta in this case would be 0 degree. I hope you have understood this case 1, students, right? So let's proceed with case 2. Case 2 is when theta is equal to 180 degree. Now look, what will be the diagram like? 180 degree. So it means that this is a vector and over here this is b vector. This is b vector. So what's the angle between these two? 180 degree. So in this case, let's find out the resultant. So what we get is r would be given by square root of a square plus b square plus twice ab cos 180 degree. Students, cos 180 degree is minus 1. So we can write it as square root of a square plus b square minus twice ab. So it can be written as square root of a minus b whole square. That is, resultant is a minus b if a is greater than b. Right? So whenever the two vectors are opposite directed, then the magnitude of the resultant is given by the difference in the magnitude of the two vectors. Right? A minus b if a is greater than b. B minus a if b is greater than a. And what about the direction? Over here also, theta is 180 degree. Sin 180 degree is 0. Isn't it? Sin 180 degree 0 means tan beta is 0. So here again, beta would be equal to 0 degree. Substitute the value of theta as 180 degree over here, you will get tan beta equals to 0, which means that beta is 0. So resultant will be directed along the direction of the dominating vector, which in this case is a vector. So students, what's the conclusion of case 2? Whenever the two vectors are opposite directed, then the magnitude of the resultant is given by the difference in the magnitude of the two given vectors, and the resultant will be directed along the direction of the dominating vector. Right, students? Okay, now let's consider case 3. Case 3 is when the two vectors are inclined at right angle to each other. When the angle between the two given vectors is 90 degree. It's like this. This is case 3. When theta is equal to 90 degree. This is the case. This is a vector. Right? And this theta is 90 degree. Like this. This is b vector. So this angle is 90 degree. This one will be the resultant. Right? So in this case, it will act as a right angle triangle. So obviously the resultant must be given by square root of a square plus b square. Let's prove it. So this is the formula for the magnitude. What we get over here is square root of a square plus b square plus twice ab cos 90. Cos 90 is 0. So we'll get square root of a square plus b square. So in case the two vectors are mutually perpendicular to each other, then the magnitude of the resultant is given by square root of a square plus b square. Right, students? What about the direction? Substitute the value of theta as 90 over here. So tan beta, it would be b sin 90 divided by a plus b cos 90. Sin 90 is 1, cos 90 is 0. So we'll be left with tan beta is equal to b by a. And you can verify it. This is a right angle triangle. This is beta. So tan beta is perpendicular by base. That is b by a. So this verifies this particular formula. Right? So in case the two vectors are at right angle to each other, then resultant magnitude is square root of a square plus b square, and the angle which the resultant makes with a vector is tan beta is equal to b by a. Right? So we are over with case 3 as well. Now case 4. Now students, whenever the two vectors are equal in magnitude, equal in only magnitude, then the resultant always bisects the angle between them. What I mean to say is that if a magnitude of A is x and magnitude of B is also x, that is both the vectors under consideration are of equal magnitude, then beta is equal to theta by 2. The angle between A vector and B vector is theta. Beta is the angle which the resultant makes with A vector. So what we are going to prove is that if the two given vectors are of equal magnitude, then the resultant bisects the angle between them. Clear students? Let's prove it. So consider this equation. So tan beta is equal to b sin theta. In place of b you can write x sin theta divided by, in place of a you can write x. Right? So it will be equal to sin theta divided by 1 plus cos theta. Now sin theta, it can be written as 2 sin theta by 2 cos theta by 2. We can easily write it. What's the formula we have used? Sin 2 theta, students, we all are aware. Sin 2 theta, it is equal to 2 sin theta cos theta, which implies that sin theta would be equal to twice sin theta by 2 cos theta by 2. So this is the formula I have used over here. Also students, cos theta, there is another formula over here. For cos theta, we can convert it in terms of sine. So what we do is, we are aware of this formula, cos 2 theta. It is 2 cos square theta minus 1, which implies that cos theta angle is made half. So it will be 2 cos square theta by 2 minus 1. So let's make use of cos theta formula over here. Right? So what do you get? 1 plus, in place of cos theta, write this, 2 cos square theta by 2 minus 1. So we are left with tan beta is equal to twice sin theta by 2 cos theta by 2 divided by 1 minus 1 get cancelled, twice cos square theta by 2. 2 get cancelled, cos theta by 2 and 1 cos theta by 2 get cancelled. So we will be left with only sin theta by 2 divided by cos theta by 2, which is equal to tan theta by 2. So what we obtain is tan beta is equal to tan theta by 2, which implies that beta is equal to theta by 2. So this is what we have proved. So students, what's the result? Do remember this very, very important result. Whenever the two given vectors are of equal magnitude, then the resultant always bisects the angle between them. Right? So let me show it diagrammatically. Suppose this is A vector, this is B vector. Both are of equal magnitude. And this is the angle theta. Then the resultant, it will make an angle of theta by 2 with A vector. Right? So if the two vectors are of equal magnitude and inclined at an angle 60 degrees, say, then the resultant will bisect the angle between them. That is, the resultant will make an angle of 30 degrees with either of the two vectors. Understood, student? So this was case 4. Now let's concentrate on a very important result which we'll discuss in case 5. Right? Case 5 is, we'll consider a special angle, that is 120 degrees. We'll consider when the two vectors are of equal magnitude and inclined at an angle of 120 degrees. Right? So, case 5. When the magnitude of the two vectors are equal and they are inclined at an angle of 120 degrees. Right? Suppose the two vectors are of equal magnitude and are inclined at an angle of 120 degrees. Now in the case 4, in the previous case we have discussed, whenever the two vectors are of equal magnitude, then the resultant always bisects the angle between them. So definitely here, the angle which the resultant will make with either of these two given vectors would be theta by 2, which will be equal to 60 degrees. This we have proved in the previous article. Now what we are going to prove is, the magnitude of the resultant in such a case would be equal to the magnitude of either of the two vectors. Like magnitude, the formula is a square plus b square plus twice ab cos theta. A is x, b is also x. So let's solve it. X square plus twice x and over here cos theta, which is the angle between a and b, which in this special case is 120 degrees. Now students, look. Cos 120 degree is equal to cos 90 plus 30. It is equal to minus sin 30. And it is equal to minus half. Clear? So let's substitute the value. So resultant would be given by square root of x square plus x square, 2x square plus 2x square. Cos 120 is minus half. So it would be 2x square minus x square, that is square root of x square. That is, resultant is equal to x. So that's a very, very important result. So what's the conclusion to it? Please listen to me very, very carefully, right? If the two vectors are of equal magnitude and inclined at an angle of 120 degrees. If the two vectors are of equal magnitude and inclined at an angle of 120 degrees, then the magnitude of the resultant is equal to the magnitude of either of these two vectors. Clear, students? So whenever the vectors are equal in magnitude and the angle between them is 120 degrees, then the magnitude of the resultant is also equal to the magnitude of either of the two given vectors. Right? So students, these were the 5 cases in the analytical treatment of triangle law of vector addition. So I hope you have understood this concept. Please go through this mathematical expression. I have proved each and every point. Right? So please do remember the results. They are very, very important. Whenever you encounter physical quantities which are of vector nature, then you have to make use of laws of vector addition. And there you have to make use of these proved results. Right? So that's it for this session, students. Do join me in my next lecture. Till then, bye-bye.